uh, this series of understanding the actual nature. Like if time is irreversible and history is written into the matter. This is what we discussed in our previous video. Then how does order, stability, and the apparent direction arise in living systems? This is another part of the argument that we want to connect to our understanding. We want to build an understanding on. So we started with that irreversibility. Irreversibility. And we would like to proceed on this understanding. We would like to proceed on this argument. And we chose both the approach of biological systems, which are purely worked out in the classical framework, and then we tried to see what's happening in the same biological systems at the quantum mechanical level. The quantum mechanical levels that are governed by Schrodinger's wave equation. And we talked about time also, where we tried to understand basically that it's the time that writes our memories. Time is something that codes our memories, that formulates our memories, that writes the script of our past in the form of present. Now, to go on from here, to go on and start making a further argument and going back to the previous argument, where we try to understand, like I would like to say that we basically observed something. We saw something that was unsettling. And what was that? That was time moves in one direction in the framework of second law of thermodynamics. And at the same point of time, we realized that history cannot be erased. This is because the time goes in one direction. So every interaction that exists in this universe, every interaction leaves a trace. It leaves a fingerprint. It leaves a signature. And yet, life does not dissolve into chaos. What I'm trying to say here is that what it does basically instead, it builds a structure. It builds a hierarchical structure. And today we are going to understand, today we are going to come up with a critical question, with an argument, a question that we would like to have some sense on. And the question is that, how does irreversible time give rise to stability? Stability. How does it give rise to stability? How do you have the organized living systems? And we would like to treat it as a paradox. And we would like to call it as the paradox of the living order. The life needs order to be in action. So if I say, according to the laws of thermodynamics, according to second law of thermodynamics, and being precise about it, what happens is that entropy, the disorder, entropy increases. And if entropy increases, there is increase in the disorder. So the disorder spreads. And it leads us to realize that the structures that are there, they keep on decaying. But at the same moment of time, and yet living systems maintain an organized way of doing things. There is a preservance of patterns. Patterns are preserved. We have preserved patterns. And we have the repetition of the mathematical functions. We have the repetitions of the functions. And this is not a violation of the physics. The functions, the repetitive nature of these functions leads to those macroscopical biological systems. It is a special solution, basically, within the framework of physics. So, we are trying to understand this order. And again, I would like to quote here, open systems. Okay? And once you have open systems and you have the flow of energy. So how would I start here again? I would start here again with an argument that living systems are open systems. They are not a kind of closed ideal systems that we choose in quantum mechanics, that we choose in physics to understand the basic nature. And these open systems, what they do is they exchange energy to the surroundings. And they exchange energy. They exchange matter. They exchange information with the surroundings. And this whole process leads to the order. So this way we realize that order is maintained. So order is not maintained here. It's not maintained here by reversing the entropy. This is the point of intuition. It's not happening because the entropy is reversing in the overall system. But what is happening here is that this entropy is exported to the surroundings. So formally, if we think about it, local order is paid for here. And this gives rise to the global increase of the disorder. Now let's try to understand it in the framework of a cell. And let me call it as a metabolic cell. So what's happening here is that you have a living cell. A cell maintains the gradients. It maintains the concentration gradients. It maintains the chemical cycles. It maintains the structural integrity of all the constituents that are present in the cell. Now, what happens here is that it does this by consuming energy. It is consuming the energy. Okay. And once it consumes the energy, what it does, it releases the heat. And releasing the heat leads to expelling waste. And if energy flow to the cell stops, if there is no flow of energy to the cell, that's utilized by the cell to maintain its life and to give the waste. What's going to happen is the order that this cell was maintaining collapses. So life is not a static kind of order. No, life is a maintained order. And as long as the order is maintained in life, by swapping the energy, the life is there. So what irreversibility has a role here? Irreversibility acts as a filter. Irreversibility does more than It does more than the time that's moving forward. It filters out the outcomes. It filters the outcomes. And once a path is taken, once a process is selected, once a journey is selected, the alternatives that could exist before the filtration, they all disappear, as repeatedly talked about the superposition in biological systems is a basis of quantum mechanics. And this filtering creates that persistence. It creates that replication. It creates repetition. It creates stability. So I should say that order, that the order of within the cell, the order emerges because not all possibilities survive. This is a very strong argument. You can maintain this order for the cell because all of the possibilities that could have been before the filtration, they die. So let's try to make a transition from quantum to classical transitions, and would like to, it's an apprehension to revisit the argument. Now again, at the quantum level, at the level of atoms, electrons, protons, neutrons, many states coexist. Many states coexist. And at the gross level, at the classical level, where the argument of biological systems start, at the classical biological level, you have just one outcome. Only one outcome remains. And this transition occurs, it occurs through thoughts. It occurs through decoherence. It occurs through the interaction between the atoms or particles or molecules. Environmental coupling. So environment as a whole has a basis, and at that basis there is coupling, there is interaction. And what irreversibility does, irreversibility locks the outcomes in place. The outcomes that you have, these are the locked realities of the nature. And let's go back to another example. The same example, the example of molecular binding. Now think about a molecule, a hydrogen molecule. A molecule can bind in multiple orientations. But once there is the binding of a molecule, once the binding occurs, the energy is released. There is binding and the energy is released. So what am I trying to talk about here is that the configuration of the molecule stabilizes in these specific shapes, specific directions, and all other alternatives that could exist, all of those orientations vanish. The system remembers only the binding part. The system remembers only those specific binding parts. So order is selected by the interaction, and interaction can be chosen as a mark of observation, as a mark of performing an experiment. And what repetition does, the repetition creates the patterns. Now, a single irreversible event is not enough. Life relies on the repetition at the same point of time. So when irreversible processes repeat, pathways reinforce. But think about what is before those interactions. Structures stabilize. The behavior of that particular action persists. And this is how the billions of patterns form. But these billions of patterns are formed out of trillions of the patterns that could exist before that interaction. Now let's try to have a formal view of stability. Let's try to materialize it. Now, if I take an example, say for example, let there be a process. Let the process repeat over a time, like a sinusoidal wave. And what you have highly probable pathways, and these highly probable pathways dominate. And you have low probability pathways. Sorry. The low probability pathways, what happens to them is they vanish. Stability is, we can call it a statistical outcome at this point of time. Out of all these repetitions. Take another example of, say for example, we talk about the enzymes, because enzymes have a role of catalysts. Now what enzyme does, an enzyme accelerates a specific reaction, boiling down of food into the smallest molecules. It does not basically explore all the chemistry that we are taught in our schools. No, it doesn't do that. It repeatedly lowers the barrier, the same barrier, and stabilizes the same transition state. That same transition state can go on and produce the same outcome. That's the most beautiful argument. To produce the same outcome out of infinite number of possibilities. And repetition under this irreversibility that we have been talking about. And what this repetition under this irreversibility does, it creates the functional order. It creates an order that maintains producing the same kind of argument, producing the same kind of word. And if we think about information, can we think about information in terms of a physical quantity? Order is not just a structure. The order that you see here, order is information. Order is persistent embedding of information. Information is stored as a molecular arrangement. Information is stored as the arrangement of atoms, the chemical states, the spatial configuration of these molecules, the states, the preferred states of these molecules. Information cannot exist without a physical carrier. This whole universe is behaving like an information storing master and leading us to new informations governed by some invisible activity. There is energy cost, and irreversible writings are making the memories possible for this universe. So the argument here is that memory requires irreversibility. This is a very strong argument that we are learning at this point of time. If we have a reversible system forgets. It erases all of its memory. So memory requires stable records. And for records to be stable, for records to be there forever and ever, you need energy dissipation. You need the loss of alternatives that could exist before you have an outcome, before you have a filtration in the hands of that interaction between the molecules. And living systems remember. So the argument here is the living systems remember because they cannot go in the backward direction. They cannot move in the backward direction. See the beauty of this invisible action, how things are going on. And if we take on the same argument towards the developmental pathways, there are pathways that appear. During development, cells differentiate. Paths close. Identities lock. All other possibilities, they vanish. A differentiated cell cannot return to its previous state. It cannot go to its previous state without an external intervention. And talking about the history, so you have the history of all these things. So history shapes identity. And you obtain an order. You obtain an order with all these probabilities. And this is something that must be emphasized. And what is it? Living order is not imposed, but it's a result. It's a result of all these possibilities. It arises from these physical constraints that this invisible action is posing down. And energy flow, irreversible filtering is there that makes it possible that history is written in universe, in the biological systems. And this goes on and on. You don't need a foresight. No foresight is required. Only consistency. Only a rhythm. Only a decency. An invisible action. And if I make a formal statement here if there are all the possible states are there, if they are all possible, if on interaction you have all the possibilities, irreversibility is something that reduces to the accessible states. Order arises because of vanishing of infinite number of possibilities. Because the system explodes in a very, very short span of time. So freedom, there's no freedom. Freedom decreases. And you can build a structure if you can put more and more constraints. The constraints are making the possibility of the structure. And why this does not violate the freedom at that point of time? This is not something like determinism here. You cannot argue in the form of determinism, because we are trying to understand it in terms of the quantum reality, and the backbone of the quantum reality is quantum uncertainty. And quantum uncertainty exists. Quantum uncertainty still exists. It will exist. But uncertainty at the same time, what it does, it operates. It operates within the shrinking of the boundaries. It causes the walls of the structures. It builds the bricks of the house. And this is how life navigates the probability. Inside irreversible constraints, life evolves. Life builds structures. And it builds structures from time to the functions. A function which has the maximum amplitude leads to that irreversibility. So you have irreversible time, and this irreversible time is responsible to produce the memory. Otherwise, you will not have any memory intact. It produces the structure. It's that irreversibility that leads to a structure that stabilizes, that enables a function out of billions of functions, giving you a one most probable that becomes the backbone of this structure. How? Through coordination, through what we call through persistence. Function is not, it doesn't seem to be planned as long as the mathematical argument is concerned. It seems to be a survive. A function survives because it has a tendency, because it has a quality, because it has the greatness that it can repeat successfully. So I think we are trying to understand the things, and would like to go with the closing of this argument. And the closing of this argument should be like this: life does not fight the time. It doesn't quarrel with the time. It doesn't put a war with the time. Life basically uses time. It uses time, and irreversibility that we have in life does not destroy the order. It doesn't destroy the order, but it maintains the historical account of the biological systems. It creates the conditions. It creates the circumstances. It creates the boundaries under which the order can persist, or can sustain, or can repeat itself. Living systems are not timeless. That should be something that we should argue at this point of time. They are they generate histories. And these histories written They are written by these irreversible steps in the arrow of time. And in that writing, their structures emerge. The buildings emerge. The cells emerge. The tissues emerge. And the biological life emerges. I hope you like this. I hope you subscribe.